Okay, so this week we have taken some time and we've looked at exponents, negative exponents, simplifying square roots, rational exponents, all kinds of things. So now we're just going to look at another topic here. We are going to simplify radicals with exponents. Okay, so if you look underneath of all these radicals, you have numbers and you have variables that have exponents with them. Notice none of them have any fraction exponents or anything like that. We're not going to worry about that kind of thing today. But we are going to look at how we can simplify those using some very simple rules. Okay, so basically right up here we've got our steps. We're going to simplify the coefficient just like we have already learned to do, like we did yesterday. Okay, so like on this first one, our coefficient would be a 27. We are taking the square root, so we're going to break it apart and simplify it just like we would any other time. Again, our coefficient is 24 on that one. Our coefficient is 8, 54, 32, and 16. And we also should probably note that some of these are square roots and some of them are cube roots. So we need to make sure we're staying focused on that. Looks like all of the evens are square roots and all the odds are cube roots on this particular page. So in order to simplify it, we start by simplifying the coefficient just like we already have. And one thing I like to do, just like I did with our negative exponents and stuff, where I drew my fraction bar and I said what lives above the fraction bar and what lives below the fraction bar. When I'm simplifying these, I like to draw my radical. Didn't want blue there. I draw my radical and I ask what lives outside of the radical out here and what's going to live inside my radical underneath of here, because certain things are going to be pulled out. Okay, so if we start by step one, simplify the coefficient just like we always have. So we have to think about, all right, 27, if we are going to break 27 apart, we're talking square roots. So again, just a reminder, our perfect squares that we would be looking for would be 1, 4, 9, 16, 25, and I'm going to stop there because just looking at this worksheet here, I don't think we're going to need anything bigger than that. And then over here on the right-hand side, and all these odds over here, they all have cube roots. So let's just remember our perfect cubes, which would be 1, 2 squared is 8, 3 squared is 27, 4 squared is 64. And again, none of these numbers on the right-hand side are big enough that we need to do any perfect cubes bigger than that we need to worry about, so we can leave it there. So let's come back over here, and we're back to the which of those numbers listed above goes evenly into 27. So we'd want to use the factor pair, the square root of 9 and the square root of 3. Okay, so as we think about, this is just equal to 3. So as we think about what lives on the outside, I am going to take the square root of 9 equals 3. This is going to live outside the radical because we took it out when we took the square root of 9 was an actual number. So the 3 is going to live on the outside. This square root of 3, notice it still has a square root with it. So we're going to leave that 3 underneath. Okay. So then once we have our coefficient simplified, then we ask, well, what are we going to do about those variables that have exponents on them? Okay. So it says, what is your root? Remember our root, if it's a square root, it's actually a 2 right there, so don't forget about that. And we always, when we're going to do this, we're going to ask ourselves, how many groups can you take out? It's like division. How many times does 2 go into 3? So how many times does 2 go into 3? 2 goes into 3 one time, which means we are going to take out 1b, okay? So it says 2 goes into 3 one time, so we put b to the first, essentially, on the outside. And then the second question says, how many are left over? Okay, that's like the remainder. So we'd have 2 goes into 3 one time with 1 left over, essentially is what that is. So we would have b to the first because there is 1 left over. So if we thought about what that kind of means, again, basically we would have that this little 2, remember there's a square root, 1 times 2 plus 1 would be 3. That's kind of how that works, okay? So let's kind of keep working through our left hand. Since those are all square roots, let's go ahead and just do the square roots ones first. So again, not to forget that that's a 2 if that's a square root. We're going to give ourselves a radical, and we're going to ask ourselves what's going to live on the outside of the radical. and what is going to live underneath of the radical. Certain things we can pull out and certain things we have to stay. Okay, so first we look at our coefficient, which is 8, and we're in the square roots. So we're going to have the square root of 4 times the square root of 2. Okay, we know the square root of 4 is just 2. By knowing that, we're taking that out of the radical, so the square root of 4 is just 2. And then that square root of 2 stays under the radical here, so it stays under the radical here as well. Okay, so then we start looking at our variables, and I say how many times does 2 go into 3? So I'm going to put my u out here. 2 goes into 3 one time with 1 left over. Okay, then I'm going to do the same thing with my v. I say how many times does 2 go into 4? 2 goes into 4 twice, and there's none left over, so there's not going to be any v left over underneath of our radical. Okay, moving on, let's look at another one here, the square root of 32. We've simplified that before. We would have the square root of 16 and the square root of 2. Again, and just like before, we're going to ask ourselves what lives outside of the radical and what lives underneath of the radical. Okay, so that's 16. The square root of 16 is just 4, so that's going to stay outside of the radical. That square root of 2 stays under the radical because we couldn't do anything with it. And then, again, we have a square root, so we're going to ask ourselves how many times, if we're looking at our x, how many times does 2 go into 4? So our x, 2 goes into 4 twice, and there's none left over. So we're not going to have any x's left underneath of our radical. Then we do the same thing with our y. 2 goes into 3 one time, so we're going to have y to the first out here, and there would be 1 left over. Okay, then we'll just do the same thing with the z. Now we're looking at our z's. 2 goes into 3 one time, so we're going to have z to the first, and there would be 1 z left over. You can put 1s up there if we want to, and that's as simplified as it gets. Okay, so now let's kind of do the same thing, except this time we're going to use cube roots. Okay, so over here on the right, and again, I put my perfect cubes up there to help us, that would help us to simplify. Okay, so I'm going to start with my coefficient, which is 24. I'm going to break it apart. I'm looking at these numbers right above, and I'm going to use the cube root of 8 and the cube root of 3. And again, I'm going to make my cube root down here. Okay, I'm going to ask myself what lives outside and what lives underneath. Okay, well, the cube root of 8 I know is just 2, so that's going to live outside. Notice I leave a space over there because I need to do my coefficient, and then I also need to do my a as well. And then this cube root of 3 didn't come out, so he needs to stay underneath. And then I do the exact same thing, except this time I've got a 3. How many groups of 3 go into 6? 3 goes into 6 2 times, so we would have a squared, and it goes in evenly twice, which means there'd be no a's left under. Okay, let's, again, just try it again. So the 54, we're going to use the cube root, and we've simplified the cube root of 54 in our notes already. That's 27 times 2. Okay, so I'm going to go ahead and give myself my cube root and decide, okay, what's living outside, what's living underneath. This cube root of 27 is a perfect cube, which is going to make 3 come to the outside. This 2 is going to stay under. Now I've got a cube and I've got an m, so I'm going to say how many times does 3 go into 4? It goes in 1 time, and there's 1 left over. Okay, and then this n1 here is 3. Remember, if there's nothing there, there's a 1. 3 can't go into 1. You can't take any groups of 3 out if there's only one n, which means that n to the first is just going to stay there. Okay, we've got the cube root of 16. Be careful not to confuse that with the square root of 16. Okay, so we're going to break 16 apart into the cube root of 8 and the cube root of 2. Here is my radical down here. It's a third. I know the cube root of 8 is equal to 2. I'm going to move this kind of far over here because I've got a p, a q, and an r I've got to deal with. And this cube root of 2 cannot be simplified. Now I'm going to do the same thing. I've got p to the first under here. 3 does not go into 1. Can't take any groups of 3 out of there, so that p to the first is just going to stay where it is. Then we look at the next one, q. 3 goes into 8, so we've got q. 3 goes into 8 2 times with 2 left over, because 3 goes into 8 2 times with 2 left over, which means we would have q squared on the outside because it goes in twice, and we'd have q squared on the inside as well. And then we do one more time. How many groups can we take out of the r's? Well, 3 goes into 3 1 time, so we'd take out r to the first. Okay, and that's basically how you do those types of questions. So good luck there. You can go ahead and finish the class kick from yesterday. Remember, we stopped after a certain number of slides, so now you can go ahead and finish the class kick.